In the previous lecture, I have explained the graphical convolution. First, we have shifted the h of t minus tau to the leftmost point, this t, right, up to here. And then we started to move this h of t minus tau towards right. Right? So this is the leftmost point, this t. And we started moving this h of t minus tau towards right side like this. Okay. Next, this come to here. This is the next one, right? Next, this come to here. This is the next one. Next, this come to here. This is the next one. Next, this come to here like this, right? This one is shifted. This one is shifted. This one is shifted. This one is shifted to right. This is like the signal is passing through the system, right? This signal is passing through this system. Let us say this x of tau is a system. This is the signal. The signal is passing through the system. Now I want to explain the shortcut of convolution of these rectangular pulses. In the previous video, I have deliberately taken the pulse widths as a different, okay, so that I got a trapezium. Okay. The previous problem is t 0 to 4. This is xt. Now 0 to, this is ht. This is 0 to 2. This is 5. This is 10. Then I got yt as 0, lower limits, this is 0, this is 0, 0 plus 0, 0. This upper limit 4 and 4. 4 plus 2 is 6, right? Yes, this is the signal I got. This is 100. Okay. The slopes are 50. The slope is minus 50. Okay. So for this, the shortcut is like, if these pulse widths, okay, these two pulse widths, these widths are unequal. If these two widths are unequal, then we will get trapezium. If these two widths are equal, then we will get triangle. Okay. So how to write this trapezium? Okay. So these are the two signals. So first, what we have to do? First, we have the output we got is, this is the output we got, 0 to 6, and this is 2 to 4. So first what I have to do is, this is t, this is yt. First indicate the extreme points. How to get extreme points? This 0 plus 0, and this 4 plus 2, or 0 to 6. This is 0 and this is 6. Next we need to find out the points where this constant exists. Okay, this is the constant line, and these are inclined lines. Okay, these are inclined lines. From where to where these inclined lines exist, and from where to where this constant line exists. So we need to identify those points. How to identify? First, identify from these two pulses. From these two pulses, identify which is the smallest pulse width. Okay, so this is the smallest pulse width. this is 2, and this pulse width is 4. So from this is the smallest pulse width. So from this 6.2, from this some point, I don't know uh, the point where it is, from 6 to this point. So this width should be smallest pulse width. Okay, this is 2. And same from this point to some point, this also should be smallest pulse width, that is 2. Between these two smallest pulse widths, we get inclined lines. So this is one inclined line, this is one inclined line. Okay, so the remaining case we get constant line. That's it. Okay, and how to identify these slopes? So this is, here we get one slope, and here also we get one slope. The slopes are, just multiply these amplitudes. This is 10, this is 5, right? Multiply these two, you will get 50. So this is increasing line, that's why you will get plus 50. This is decreasing line, that's why you will get minus 50. That's it. So here you will get plus 50, minus 50. Once you get slopes, then you can easily write this point. Okay, this point. How much? So this is 2. This width is 2, right? 50 into 2. This is 100. That's it. And this is 0. This point. This width is 2. So they will get 2, right? And this is 6. And this width is 2. So 6 minus 2. This is the point 4. That's it. Okay. So if these pulse widths, if these two pulse widths are unequal, then we will get a trapezium, right? That's it. We'll give one more example. Let's say this is x of t minus 2 to, let's say, 6. This is h of t. Let's say this is minus 1 to 3. Okay. Then the convolution. This is t. This is by t. First, identify the extreme points. This is minus 2. This is minus 1. So this is from minus 3. And this is 6 plus 3. So minus 3 to, let us say this is 9. And this pulse width is 8. And this pulse width is 4. Right? The inclined points are at 4 units from the extreme points. The inclined lines are from 4 units from the extreme points. Okay. So from this to 4 units, let us say some point here. So this point must be 4 units distance from the 9, that is 5. From minus 3 to 4 units distance means it must be up to 0 it is 3 units, and up to 1 it is 4 units. So between these points we will get inclined lines. This is inclined line. This is inclined line. Okay. And between these 1 and 5 we will get constant. And slopes. So I haven't given any values here. Let us say here the slope, here it is 5 and this is 2. Okay. So the slopes are 5 into 2. here minus 10 slope, this is plus 10. So if you get slopes, this amplitude you can easily get. This width is 4, right? So 10 into 4, this is 40. That's it. Now that's it. Okay. Now I will give one more example. Let us say this is xt. Suppose this is 0 to 4. Let's say this is 5, and ht 0 to 4 only. I want to take equal widths. xt is 0 to 4, yt also 0 to 4. Now first identify the extreme points. 0 plus 0, this is 0, and 4 plus 4 is 8, right? Next, smallest pulse width from these two. This also has 4, this also has 4. Okay, 4 only. The inclined lines are 4 units away from the 0 and 4 units away from the 8. Okay, so 8 to 4. This point is 4 units away from the, that is 4. 8 minus 4, 4. And this point is also, and one more point is 4 units away from the 0. So 0 plus 4 will get 4 only. Okay, so from here to here, here to here we have one inclined line, and here to here we have one inclined line. There is no constant part. Okay, now the slopes are 5 into 2, 10. This is minus 10. Multiplication of these two amplitudes, that is the slope. Once you get the slope, then easily find out this point, this amplitude point. So this length is 4, 10 4 is 40. That's it. Okay, let us say this is xt, right? 0 to 2 is xt, is 10, this is ht, 0 to 4 is 5. So if you want to find out xt convolution with ht, so yt equal to xt convolution with ht, right? First what I do is, first I will find dy by dt, that is dx by dt convolution with ht, or xt convolution with dht by dt. First I will find this, and then if I find this or this, I will get dy by dt. Okay, then again I will integrate it, then I will get yt. That is how I will find out. Okay, so first what I will do, I will do this one, dx by dt. First I will find out dx by dt. X is given this xt from 0 to 2 is given as 5, 10, x2, this is 10. I want to find out dx, this is t, dxt by dt. Okay, so here at t equal to 0, this is the discontinuity and it is constant, and again we have discontinuity at t equal to 2, right? So if I differentiate this signal, what I have to do, if I differentiate the constant, let us say 0 to 2, 0 to 2 I have constant, this is 10, right? If I differentiate a constant, I will get 0, 0 to 2. But At exactly t equal to 0, we have this discontinuity, right? So the slope of the discontinuity is infinity. dx of t by dt is nothing but slope only, right? And at t equal to 0, that is the slope at t equal to 0. But we have slope at t equal to 0. This is a vertical line, right? This is the vertical line. This is the vertical line. The slope of the vertical line is infinity. So we have to replace dxt by dt. We have to replace that discontinuity with infinity. So to represent infinity, we have only del t. Okay, but we have amplitude of 10 is there here. So we need to replace with 10 into del t. Okay. So at t equal to 0, we have discontinuity, and that to increasing signal. This is 10. Okay, if I represent 10, that area is 10. And at t equal to 2, we have discontinuity, and that is decreasing. So we have to represent this with like this minus 10. Okay, or you can write this signal as u of t minus u of t minus 2, right? 10 into, to differentiate this dxvt by dt, 10 into, if you differentiate this, it will be ut become del t, and ut minus 2 become del t minus 2. That's it. That is what I have written here. That is what I have drawn here. This is 10 into del t, and this is minus 10 into del t minus 2. Okay, now I convolve these two signals. This is dxt by dt. Now I have ht, right? I convolve this. Now ht can be written as this one, ht ut minus ut minus 4 into 5, right? I already told you how to write in terms of ut. So now we convolve this with this signal dxt by dt. So y d by dt of yt equal to dxt by dt convolution with ht. Dxt by dt is this. This can be written as 10 del t minus 10 del t minus 2 convolution with ht. Ht can be written as this one, ht 5 into ut minus 4. This 5 into ut minus ut minus 4. Now 10 into 550, that I can bring outside. Next, del t convolution with ut. You will get ut only. Convolution of any signal with del t is that signal itself, xt only. So here ut convolution with del t is ut. Next, minus ut minus 4 convolution with del t. You will get ut minus 4 only. Next, minus del t minus 2 convolution with ut. Minus ut minus 2. I'm just applying the properties, right? Next, minus into minus plus del t minus 2 convolution with ut minus 4. You will get ut minus 4 minus 2. So this is 50. This is ut minus ut minus 4 minus ut minus 2 plus ut minus 6. Okay. So you write them in order. 50 ut minus ut minus 2 minus ut t minus 4 plus u t minus 6. This is the signal. This is dyt by dt. Okay. First draw it, then integrate it. First I will draw it. This is 15 to u of t. Next one, minus 15 to u of t minus 2. So this is minus 15 to u of t minus 2. Next one, minus 15 to u of t minus 4. So I will represent with another color. This one, minus 15 to u of t minus 4. Next, plus 15 to u of t minus 6. From here, plus 15 to u of t minus 6. All these things should be added. All these things should be added. So 0, this is 2, this is 4, this is 6. From 0 to 2 only 50, right? From 2 to 4 we have minus 50 and plus 50. So here to here plus 50 there, here minus 50 there. So you will get 0, 2 to 4. Okay. Next 4 to 6 we have minus 50 is there. This blue line, green line, again above one blue line. This is 50. Here one blue line minus 50, one green line minus 50. Okay, if you add these three you will get minus 50. This is minus 50. This is plus 50. Next, from 6 we have two lines again. Above this is 100, below minus 100. If we add these two you will get 0. So this is at 6. This is at 6. I have 0. And after 6 also it is always 0. And after 6 and after 6 also always 0. 100 minus 100, 100 minus 0. This is the signal. This is dyt by dt. Now I want yt, right? So I need to integrate it. Okay. If you integrate step signal, you will get ramp, right? Ramp with the slope of the size. So suppose some k into ut is there. Then if integrate it, so integration of some constant from 0, right? So you will get some k into t. Okay. So k is the step size. So but here it became slope to the signal, k into t, y equal to mx, slope to the ramp. Okay. So if you want to integrate the signal, we need to replace the step function by the ramp signal and with the slope of the step size. Right. This is y of t. I am integrating from 0 to 2 and 2 to 4 and 4 to 6. Now from 0 to 2, 50 step signal is there, 50. So we need to replace the step by ramp with a slope of 50. So from 0 to 2, the slope of 50. Slope 50 means this value 50 into 2. This is the horizontal. 50 into 2 will get 100. 2 to 4. This is 0. To differentiate some constant, you will get 0, right? So if you differentiate this signal y of t, you will get dy by dt, right? Differentiate this. So If you differentiate this constant, you will get 0 only. Okay, 2 to 4. Next, 4 to 6, we have minus 50. So we have to represent with minus 50 slope. So if you write a line with a minus 50 slope, this is minus 50. This is minus 50. 4 to 6. So you can easily find the amplitude. 6 minus 4, 2. 2 into 50, 100. 100 is there. Discrete and signals, linear convolution. I can explain one example and leave it. X of n, just say discrete time signal, some 1, 2, 2, 1. Okay, this is a discrete time signal. Let us say it starts at n equal to 0 here. Okay, the represent arrow mark, that is the index, the indication of 0. Then let's say h of n 2, 4, 6, 1, 2. This starts at n equal to 0 here. Okay, the extreme limits, this is n equal to minus 1, this is minus 2, this is minus 1, plus 1, plus 2, plus 1, plus 2. The extreme limits, here the extreme limits are minus 1, minus 2. So yn exists from minus 1, minus 2, minus 3 to, next these extreme limits, plus 2, plus 2, 2 plus 2, 4. Yn exists from minus 3 to 4. That we have to keep in our mind. Next, how to do the convolution. Actual formula is yn equal to sigma k equal to minus infinity plus infinity xk h n minus k. This is what we do, but here sigma k equal to xk. Only xk exists from minus 1 to 2, right? K, x0, x1, x2, and so x minus 1 up to k equal to minus 1. This is the lower limit of xk, and the upper limit of xk is up to 2. Xk and h n minus k. Okay. If you want, you can expand this. X of minus 1, h of n plus 1, plus x of 0, h of n, x of 1, h of n minus 1, x of 2, h of n minus 2. That's it. This is y of n. Substitute y of 0, n equal to 0, and in the equation substitute n equal to 0. So we are doing multiplying the signals and adding, multiplying and adding, multiplying and adding, multiplying and adding. Okay. In case of continuous time case also, we are multiplying the two signals and integrating there, but here summing. Okay, because this is the discrete time signal now. So this is what we have to do, but we have a shortcut is there. There is a tabular method. We'll explain that. This is the tabular method. X of n, this x of n, h of n, h of n. I will write them. X of n 1, 2, 2, 1 here. So 1, 2, 2, 1, and the starting point is at n equal to 0 is here. This starting point, and hn 2, 4, 6, 1, 2, particularly 2, 4, 6, 1, 2, and the starting point is at n equal to 0 is 6. This is the starting point. Okay. Next, is a tabular method. Multiply each element of h of n with x of n. So 2 into 1, 2, 2 to the 4, 2 to the 4, 2 1 next 4, 8, 8, 4, 6 to the 12, 12, 6, 1, 2, 2, 1, 2, 4, 4, 2. Now draw like this: 1 element, 2 elements, 3 elements, 4 elements, again 4 elements, 3, 2, 1. So these are y of n's. This is y of n. To add add these two, 4 plus 4, add these 3. Okay, add all these things. 2 comma 4 plus 4, 8, 8 6, 14 plus 4, 18, 20 plus 2, 22, 23. Next 12, 4, 16 plus 4, 20. Next 12, next 5. This is yn. And where do I need to indicate arrow? That is important. Okay, the start set here, extreme points. The extreme points are yn. Already told you, this is -3, this is 4. Okay, extreme points. So this point is -3, -2, -1, 0. Okay, here we have to indicate the arrow mark. This is 1, 2, 3, 4. That's it. Yn exists from -3 to 4. Okay, this is the linear convolution. Okay, and ultimately we need at the output linear convolution only. So I will discuss the circular convolution when I explain the DFT. There the things will be cleared. Okay. So without knowing the DFT, I can't explain the circular convolution here. Okay. When I explain DFT, there I will explain the circular convolution. There the things will be cleared.